Hi everyone, welcome to the Ask Dr. Lin show where I answer questions that hit BAKERpedia.com daily. I am Dr. Lin from BAKERpedia, the world's largest place for technical baking information and the only place you should go first when you need all your technical questions answered on the go. What I usually do on the show is to answer the questions that concerns commercial bakers. Yes, you know when blisters and mottled skin on your bread keeps persisting at 100 cuts a minute? Who has the time to do an hour-long research on the internet? Well, this is what this show is for. Place any comments on the topics that you are researching on BAKERpedia, and I'll do my best to answer them on this show. All right, today's show is brought to you by Diasna. With their wheat plant compact line, you can easily produce flour preferments in one piece of equipment that ferments and cools it in a well-controlled environment. Learn more at diasna.com today. Today's show is on flour preferments. Before I start, just remember that I will be using flour brew and flour preferment interchangeably. This is because they are the same thing. The flour brew uses a small portion of flour in the starter liquid sponge. This method is a compromise between a straight dough and a sponge and dough method, somewhere in between. Also known as a flour brew or liquid sponge, it contains more water than flour to keep the mixture pumpable. In high-speed systems, pumpable flour preferments have higher efficiencies, better accuracy, and has a more consistent quality. In the US, this form of flour preferment is preferred over many other dough systems. Like a sponge system, a flour preferment contains a portion of the total flour, sometimes about 10 to 50% in the formula. This means that flour is added to the brew during blending and ferments in the tank for 1 to 3 hours. The rest of the ingredients are then added into the dough stage. Dough mixing time at the mixer is a function of flour in the brew. As in the sponge and dough system where more flour is fermented and matured, less mechanical development of the dough is needed. Therefore, as flour increases in the brew, dough mixing time will be reduced. And as flour decreases in the brew, mixing time is going to increase. Water, yeast, sugar are first blended, then pumped into a blending tank where the flour is added. When thoroughly mixed, it then gets directed into a fermentation tank. Through a series of fermentation, this is about 1 to 3 tanks, this fermentation process may last up to 3 hours. After that, it then goes into the heat exchanger for cooling, then held in the refrigerated holding tank till it is needed. It is refrigerated at 38 degrees Fahrenheit or 3 degrees Celsius. After the refrigerated holding tank, it gets back to the batch weighing tank. At this point, it dispenses directly into the mixer where the remainder of the flour and dry ingredients are mixed into a fully developed dough. For a typical white bread or bun product using the flour brew method, here's an example. About 40% of the flour goes into the brew with 50% of the water, all the yeast, and about 1% of the sugar. As you can see from this table, other than these 4 essential ingredients, everything else goes into the dough portion, including minor ingredients like fiber, non-grain flours, and salt. The answer to this is really dependent on your water quality. How would you know if you have hard or soft water? Check with your annual report from your municipality and determine if you have hard or soft water. Hard water quality usually means that you have enough mineral content in there to help the yeast. Though this may not be good for your broiler or other equipment, I really believe that this is where plants go wrong. They soften the water for their broiler and then uses that same water for fermentation. My advice is to bypass the water softening system for any water used for fermentation. Remember, hard water gives a stronger and faster fermentation, and time is money. So work with me here, okay? So when do you add yeast nutrients? Go to our yeast nutrient page to learn more. When you really have soft water or water lacking in calcium and magnesium, which are key cofactors in the metabolism of yeast cells, you need yeast nutrients. Yeast nutrients are also beneficial to the health of your yeast during fermentation, especially if you overstress your yeast using fast fermentation with long holding times. Yeast nutrients with ammonium sulfate, ammonium chloride, or diammonium phosphate supplements the nitrogen and phosphorus that are vital to sustain the yeast. While yeast nutrients like biotin helps the yeast ferment the sugars faster. Thus, faster fermentation, again, remember, time is money. This again depends on the flour quality. Do you have good quality flour? Go to this page and learn how you can understand your flour quality a little better. Indicators of good flour quality are longer stability times and lower MTI. Well, if these are bad, then you have a poor quality flour. So it would be a good idea to add dough conditioners into the flour brew stage to give the flour gluten proteins a little head start in oxidation. This also strengthens it up before the final mix. Don't forget, green flour or flour straight from the mill has a lower quality than real car flour. In this situation, yes, you should put dough conditioners into the flour brew for the green flour. But no, you do not need to put dough conditioners into the brew for the aged real car flour. Let's take a short break to shout out to our sponsor Diosna and their continuous pre-dough production, which produces consistent pre-ferments up to 2,100 gallons. This system consists of several fermenters for production, maturity, and storage. If you need to go from a 20% to a 40% brew, their continuous pre-dough production has the ability for different pre-ferments to be produced and stored due to variable fermentation times and flexible agitation systems. Go to diosna.com today. As mentioned previously, a flour brew has more flour than a water brew and less flour than a solid sponge. As you go up on the level of flour in the flour brew, more buffering will occur. This creates a more stable brew system. The physiochemical changes that occur in sponge and dough also happens in a similar fashion within the flour brew. At a low 25% flour level, utilization of damaged starch is much less. For this reason, there needs to be additional sugar added together with calcium carbonate for some buffering. At a 40% flour level and above, little or no sugar or calcium carbonate is needed. Less fermentation time is also needed while there is no increase in fermentation temperature. Not only does this provide a better environment for the yeast by buffering the pH, but it also improves the flavor profile of the brew. With extra hydration also comes a reduction in mixing requirements and an improvement in dough processing. This would help reduce the amount of dough conditioners used. Please note that as you go higher with the flour in this system, a reduction in the fermentation temperature and an increase in the fermentation time should occur, sometimes up to 3 hours for 40% flour brews. Once in the fermentation tank, the brew will ferment for 3 hours at about 78 degrees Fahrenheit or 26 degrees Celsius in a jacketed tank that permits this temperature to be maintained. Keep it at a lower temperature so that you can reduce foaming. Foaming will affect its density and the ability to keep metering consistent. After fermentation, it is usually cooled through a heat exchanger into a bulk holding tank, and it's kept at that temperature for a while at about 38 degrees Fahrenheit or 3 degrees Celsius. How do you know if you ferment and cool correctly? Use pH or TTA. TTA is also known as titratable acidity. You can use pH or TTA to monitor the acidity of the brew. Flour brews at this point should have no less than pH of 4.6 and a TTA of 8. The advantages are that the crumb is more open than a straight dough and more uniform than a sponge dough. There's less capital needed for equipment purchased upfront as compared to a sponge dough system. It uses less floor space than a sponge dough system. As compared to straight doughs and water brews, flour brews have faster mixing times. It also uses fewer dough conditioners, and it has more flavor intensity than straight dough systems. It is also the best system for use in a continuous mixing process. The disadvantages are, as compared to water brew, this is more labor intensive and cleaning or sanitation is more difficult. Most systems need a CIP or clean in place setup. So that requires additional pipes, tanks, chemicals, and water pretreatments. This system also requires more capital investment than water brew, as larger capacity heat exchangers and holding tanks are needed. The higher the flour level, the more investment is needed in the equipment. Unfortunately, it has less flavor intensity than a traditional sponge and dough system. This system is targeted for long runs with little or no changeovers and is thus not versatile with formula changes. Alright, need more questions answered on flour brews? Send them to askdrlynn@bakerpedia.com. Thank you for joining me today on Ask Dr. Lynn. Some of you ask me how I do this for free. Well, I do it through sponsorships. Remember, BAKERpedia can't be and I can't do what I do here without our sponsors. So I'm thankful to sponsors like Diosna. This episode is sponsored by Diosna, the dough experts. Check out their wheat plant compact line that offers flexible production of flour brews. You know how some systems may create gluten washout? Not this system. Their gentle mixing action with individual stirring speeds and rest times prevents any kind of gluten separation. Want to learn more? Go to diosna.com today. Alright, before I go, please like and subscribe to this channel. See you the next time.